Dear students, today we will learn about a very important topic of machine learning, which is decision trees. So decision trees are very basic and very important. And based on the decision tree, we have a random forest as well. So the random forest is basically a combination of that one. So there would be some different concepts which would be used in the decision trees are like entropy, which is impurities, measuring the impurities, and there is also another very interesting topic which is called Gini Index, which is also used in economics, but we will use it here as well. And along with that one, there will be about some random forest algorithms like bagging methods or the kind of methods we will also discuss in it. So let's quickly see what we have in this one. What is a decision tree and how it is important in machine learning. So these are the references you can just like refer to, and then you will have like a lot of information about this topic. So basically, the trees could be like it could be binary, or it could be like there could be like many roots for that one for the tree. So basically, classification tree is a algorithm where we like target variables is a fixed or categorical, or we can say that there's a class within a target variable most likely into the fall. So first, for example, if you categorize two things like for example gender, so male and female, we can create like for example categories of cars like with respect to the brands like Toyota, Nissan, or Kia or Hyundai. So there are different like categorization you can do it, right? So the classification type, it would be determining who will or will not subscribe to the digital platform, or who will or will not graduate from high school, right? Regression trees refers to algorithm like we target variable, and this algorithm is used for to predict the values. So example of regression type problems would be like to predict the selling price of residential houses, which continuous dependent variable. And then this will depend both on continuous factor like square footages we have it, as well as categorical factors, or could be like style of the home, area in which the property is located, and so on. So this was just like the brief discussion or the definitions you can say. Now the forms of the DT means decision trees you can see here. So as I told you, it could be a binary or it could be like a tertiary. So here is the binary one, okay, and you can see how the binary split is being done. Okay, so here we can see the regression tree for the log salary as well. So definition. So it's a tree-like model which illustrates series of events leading to a certain decision. Like every node, like each node represent a test on the attribute, and each branch is the outcome of that test, right? So you can see for the students, if you're a student, yes or no, if your income is high and low, if your age is greater than 30 or less than 30, if your credit score or credit record is fair or excellent, or if your income is like low, medium, high. So here there are three like roots. On the income there is only two roots, on the student there is a two roots, right? Credit records two roots, age is two roots, right? So these are like you can say here like for example we can solve certain problems like for example whom to give the loan. Like for example, say it should not be a student, it should be like 45 years old, medium income, fair credit his record, like for example. And if it is a students, it should be 27-year-old, low income, excellent credit record, right? So like so this is like some certain criteria, and this criteria can be fulfilled with the decision tree. Since decision trees can be automated with a computer, so that's why it becomes easier for us if you have a lot of data. So see, you can we parse through the tree, and from student to the income to the credit record to the fair and age, like, and then you can say yes, right? The decision is yes for this one. And similarly, if there's a decision no, even the student's income, credit, like for example, excellent, age is less than 25, we say clear no to that one. So we use label data to obtain like suitable decision tree for future predictions. Like we want a decision tree that works well on unseen data while asking for the few questions as possible. Like so, our label should be like either yes and no. For example, play tennis or not play tennis. So depending on the different factors like the weather is sunny or rainy or overcast, the temperature is hot or mild or cold, humidity is normal, high, okay, and wind is weak and strong. And then according to that one, we decide whether should we play the tennis or no. Yeah, so now here is like, certain decisions, for example, outlook, and this one, humidity is, for example, normal, then we have to play. If the wind is like, weak, we have to play, okay, overcast, yeah, then definitely yes, there is no like, questions for not playing. So these are like, different decisions, like, ways. Okay, so here you can see where are the yes and no's. You can see here basic step, choose an attribute and based on its value split the data into the smaller set, and then we have to recursively repeat the steps until we can be more sure that whether which label to decide or not to decide. So here we have three different classes we made it right, with the sunny how it works. Yeah. So, and another one is the humidity level, yeah, how the humidity level affects that outlook. And then we see the like, humidity is higher, humidity is normal, okay, and then accordingly we get different decisions. So we have to recursively see it. Here is the like, algorithm for that one, that how we need to make like, define some tree, and then we have to label it, and then majority label it will go for X, else it will go for splitting further, and then it will like append the different child. So this is the algorithm, and we can have some code for the Python, and this Python code is like, it works well. What's a good attribute? Like, yeah, is for example, yeah, in this one we have like, mammals and birds. So whether to see whether it's a bird or mammal, does it fly, color. So based on the fly and color, we can decide it. And then we have like, colors, brown and white, okay, 33% mammal, 66% bird, and 50% mammal and 50% bird, right? So yeah, so these are like, fly yes or no. 100 yes is 100% bird, and no 75% mammal, and 25% are bird, because some birds cannot fly. And color, like, white color has more like, 50% are white colors, usually considered to be 50% mammal and 50% bird, while in like, brown, it is observed that 33% are mammal and 66% are bird, right? So now we can combine, because the resulting subset are more pure. Then knowing the value of the attributes given us the information about the label, and the entropy of the subset is lower. So lower means like, entropy means impurities, like, the pure. For example, pure means like pure mammal, pure bird. Impurity means the mix, like, some like, species of the birds are mixed with the mammals, or some species of the mammals are mixed with the birds. So that is called impurities or entropy. So entropy is a very interesting factor, and mathematically we can calculate that one, and it helps us to remove the impurities from our decision. For example, like this one. So here in the fly, 75% is mammals and 25% are bird. So this 25% is impurity here. While in this one, like in the another one is the color wise, like brown. In brown, 33% is like, impurities. Or if you're considering mammals, then 66% is impurity if you are considering mammals. So information gain, if we can have it through two important like mathematical things, which is called entropy, and second is called information gain. So what is entropy? So entropy is basically measure the degree of randomness in the data, how things are random. So for example, in a basket, like we have mixed like, fruit, so it has high in entropy, like, there is like high impurities, while in only green apples we there is low entropy because there is no mixing, right? So that's like, low entropy. So for a set X with the K classes entropy, so this is a formula minus summation pi log 2 pi. So pi basically is the probability. So we take the log of the p probability and multiply with the probability itself. So usually, I just like to highlight this thing, what we have it, to explain this formula for you. Basically, this is the probability, okay, the summation probability, because this works as summation, so all the probabilities, right? So probability for like this apple, probability for this apple, or here probability for this, like strawberry for apple, for like apricot or something like. So all this one. So yeah, so the summation of all the probabilities, summation of all the probabilities multiply with the log of the probability and log 2, right? So basically it reduces. So if I multiply pi multiply by pi, this is more, right? This is like this value is greater than this value. Why? Because this one is like higher, the square is higher than this one, so basically it reduces a bit the values of that one. So this is my observation on that one, and it works. So where pi is the proportion of elements of class x. Yeah, so let's see, let's go to the next slide. Okay, entropy for the two classes. So here you can see how the entropy works. So it starts from like 0, and the maximum it goes to 1. All right, and so low entropy implies greater predictability, right? So here, like in the all are green apples, so entropy is low here. So we can easily predict that the apple would be, or anything which I pick, it will be the green apple. But here impurity is very high on this basket, because we have the strawberries, we have the bananas, we have like apples, we have cherries, so all mixed together. So in this one, the impurity is high, entropy is high, and predictability is low, right? So low entropy, like so when entropy is high, predictability is low in that case, right? So let's see for this one, information gain. Okay, so the information gain of attribute is expected reduction in entropy due to the splitting on the values of A. So here, like information gain. So information gain is one of the most important concept introduced in 1995 by a very famous electric engineering scientist, and that was Shannon. Right? Shannon introduced this concept, and because of this one, we have now this laptop, we have mobiles, and all these things. So this is very important, like information, and you must read that article. I think you can find on the internet that article, which is published by Shannon in 1945, before the World War II, I think. Yeah, probably. Yeah. So the information gain of the attribute A is expected reduction in entropy due to the splitting on the values of A, right? So where xv is the subset of x for which A is equal to V, right? So this is the formula for information gain, and you can see the entropy of x, entropy of this one, and then we make a summation of that values, and we get the gain of it, right? So best attributes, highest information gains. So what is the highest information gains means, like how can we find? Yeah, so in highest information gains, we basically calculate all the probabilities. So intro minus p of log of p for the mammals and the birds. So we calculate both, and we make it like we add them up, and after that one we get a entropy of 0.98. So this is one of the way, and I hope that you can easily find the log of 2. We can use the calculator to find the log of 2 of 3 by 7, and you can easily find it. Entropy, and so this is the entropy of that one, okay. And the gain of information is 0.985, and then you get the final result. So you have yeah, two most important information here, like entropy for x, and entropy for x when the color is brown, okay, and then for that one you get like a 0.02. Okay, and then you for the fly entropy is 0. Okay, in that case. And here is the end of this session. In the next session we will see again.